Okay, great. So we are still solving questions of the teacher licensure exams July 2025. Previously, we solved the question 1 to question 6. Today we are going to look at the question 7 to question 11 since some of the teachers, uh, some of them are going to sit the October paper. Let's go through all these questions so that in case they get similar one or they meet the same, they will be able to know how to go about it. So kindly follow me, have patience and follow me as I take you through all these questions. This is Maths TV and my name is Evans Okain. I'm still your mathematics facilitator. Kindly search Maths TV on YouTube. You can also search TikTok. If you go to TikTok, go straight to my bio. The YouTube link is there. Kindly click on the YouTube link there. It will take you to my YouTube channel. When you get there, please kindly subscribe, like, and share. Okay, yes. Um, let's begin. Thank you for your time. Now let's take our first question, which is the question 7. Okay, yes, so this is the question set. But before we do this one, let me clear this. Some people were also arguing that the question numbers they have been seeing in this video is different from the question numbers some of the teachers got when they sat the July paper. So what happened was that the questions, it is not different, okay? The questions are the same. The only difference is that somebody's question 1 may be somebody's question 10. So if someone is answering question 20, somebody may be answering the same question as question what 40. So it's only the question numbers that differed, okay, but the same questions, the same answers. All right, yes, so that is what happens. So this paper you see here, the question numbers you may see, for instance, this question 7 you see here, the same question may be somebody's question what 30, so it doesn't change anything. Okay, if that's the case, then let's begin. So in this question we are saying that the graph below represent the type of t-shirts a group of teachers ordered for a speech day. We are to use this graph to answer question 7 and 8. So in this question, we are saying that if each teacher ordered only one t-shirt, how many teachers placed the order? Good. So looking at this graph here, you see that whenever we are going to buy t-shirts, you look for your size, okay, and the size are in this category. We have the small size, medium size, large, and extra large. So these teachers, they had their preference when it comes to the size, okay. So we have people who decided that as for us we have our small size, as for us we want. So some people ordered for all this size. Good. So the question is asking us to find out the total number of teachers who ordered for this. So how do we do this? All that you do is you need to find the number of teachers that ordered for each of the size, okay. You need to know. So if you take the small size, how many teachers ordered for the small size, you need to know. So you see that the column where we have number of teachers, that is what the numbers there on the vertical line, they represent what the number of teachers that ordered this particular t-shirt. So smaller size, let's see, you see that the bar is between 8 and 10. In that case, then we can conclude that it is what 9 people ordered a small size. Now let's move on to medium. What about medium? Medium to, you see that is between 12 and 14. Then we can also conclude that 13 people ordered. Then for large, you see that it's also straight on what 6. So 6 people ordered for large, and the same thing 6 ordered for what extra large. So once you're able to identify all these numbers, then how do you know find the total? It's just a matter of what summing them up, okay. You just add them and then you are good to go, okay. So if you add them, what are you getting? 34, and that answers what the question. So our answer is what? The A. Okay, so Very simple. All right, great. Yes, great. So you see that it's very, very what simple. So when you get questions like this is how you go about it. Okay. Once it is drawn for you, you just have to know the number of teachers that choose each of the size of the t-shirt. Okay, and then you just add them. Whatever you get becomes your answer. So that answers the question 7. Now let's move on to the question 8. Okay. Yes. So for the question 8, let's see. Okay, great. So we have what this. We are saying that how many um, more medium t-shirts were ordered than large size. So this one we are comparing those who um, chose or those who ordered for what medium t-shirt and those who ordered large size. We just have to compare and find the difference. Okay, so you see that. So let's look at the graph again. Okay, yes. So this is the graph. Let's look at the medium t-shirt, which is we saw that 13 people or 13 teachers ordered medium t-shirt, and how many also ordered large? We realize that 6 people. So if you compare the two, it is clear that those who ordered the medium, they were many more than those who ordered hot, the 6. But how many of them were they more than that those who ordered the large? It's just a matter of finding the difference. Okay, subtracting the smaller from the bigger. Whatever is left becomes your answer. So it's just 13 minus what 6, which gives us what 7. Okay, very simple, and that answers the question, and that gives us what the option what A. Okay, yes, very basic. All right, good. Now, if that's the case, then let's move on to the next question, which is the question 9 and the 10. Good. So for question 9 and 10, let's tackle them one after the other. For question 9, we are saying that a head teacher ordered exercise books from a stationery store. The books are supplied in packs of 5 and 6. What is the minimum number of packs of the exercise books the head teacher will receive if each of the packs is supplied? So this one, if you look at this question, is a little bit what tricky but very simple. Okay, if you here, if the books are supplied in what in packs of 5 and 6, then we need to find the common what multiples. Okay, the common multiples of this 5 and 6. Then once we find the common multiples of this 5 x's, then we choose the one which is what minimum, the smaller. Okay, so in this case, this question is just a matter of finding what the LCM of what 5 and 6. Okay, it's just finding LCM of 5 and 6. That is what this question is talking about. So when you get similar questions like this, it's just trying to say that find the LCM. The LCM means what the least common multiples. Least common multiples. So when we say least, it's the same as one minimum number. So we want to know the least number. Okay. Yes. So before that, we need to find the multiples of 5 and 6. Okay. So what are multiples of 5? We know that multiples of 5, we can get what 5, starting from 5 we get 10, we get 15, we get what 20. It's just a matter of adding what 5 5 5 5 5. Okay, you add 5 continuously, then we have 25, 30, 35, 40. We can go and go and go to infinity. Okay, yes. Now, that is what multiples of 5. We also find multiples of 6. So for multiples of 6, we can start from 6, the number 6 itself. So 6, we increase it by what 6 again, which is 12. We increase it by 6 again, which is what 18. So it's just a matter of adding what 6, 6, 6. When we say multiples of numbers, the particular number that you are saying multiple, you are only what adding that same number to itself. Okay, as you are moving, you add it to itself. So we have for 30, And then we have for 36, we also have 42, 48, and to infinity. Okay, great. Yes, so that's what we are saying. Okay, so once we are able to find the multiples of the fact, then we choose which one is common, because we are saying that least common hot multiples, which one is common and the least among them. Okay, because there are times that if you continue and find them, you get more of them, you get double hot numbers which are hot common, but you choose the least, the smallest. So looking at this, you realize that if you go, we have what, 30, which is hot common, and that is the smallest common multiples of these two numbers. Okay, yes, so we have 30 for in 5, and we also have for 30 in 6. They are common. So once you are able to find this common, then that becomes your answer. And so it means that in the option we have B as what, our answer. Have you gotten that? So that is the LCM. Okay, the LCM now is 30, and if the LCM is 30, then we have option B as an answer. So as I said initially, that if you look at all these questions, they are very hot, basic hot questions. Okay, so when you meet similar questions, or you solve questions like this is how you go about it. Now let's look at the question 10. So for the question 10, we are saying that the standard deviation of a set of scores of 90 students in a mathematics test is 15. If the score of each student is decreased by 9, what will be the standard deviation of the new observation? So for this question, when it is given to you like this, you may think that it needs calculation. This one, there's no need for calculation. If you understand the properties of standard deviation, then this one you don't even need any calculation. You can just choose the answer. For standard deviation, we are saying that it's just what a spread of what data around what the mean. Okay, yes. So whenever we add a constant, okay, whenever we add a constant to the data set, it doesn't change the standard deviation. Whether we subtract a constant number from each of the hot of the data set, it will not affect the standard deviation. That is what we are saying. That is one of the principles, or one of the properties of standard deviation. So this one, we are saying that each of the scores, okay, each the scores of each of the students was decreased by 9. The fact that the scores, each of them was decreased by 9, doesn't mean that standard deviation, which is given as 15, is going to be affected. It will not affect it. Okay, so I have a similar example, a scenario here. So let me take these examples and explain to you. Maybe you get the understanding better. So let's say we have this data set. Let's say we have 1, 2, and 3. Let's take these three sets, these three numbers. Now, if you are to find the standard deviation, we know that standard deviation is given as what, square root of the sum of squares, of the data set divided by the number of what set, minus the sum of what, then the set divided by the number of set, all squared. Okay, yes, that is the formula for finding the standard deviation of what data set when you are giving them in this form. Okay, so let's find the z gamma x squared. So for z gamma x squared is let's look at the z gamma x first. It's just a matter of what, summing the individual scores. So let's take this as our scores. We have a first person scored 1, the second person scored 2, the third scored what, 3. So if you are finding sum sigma x, it means that we are summing the individual scores, and we get what, 6. Then let's find the square. So it means that the individual scores, if you square each of them and sum them up, what are you getting? And that is what we have here. So you square 1 plus you square 2 plus you square 3, whatever data set is given to you, you need to square each of them and then sum them. So the sigma you see here means what, summation, addition. Okay, so once we're able to get all this, and we know that the n is the number of what they said, that is 3. Okay, good. Yes, so this is what we have. Okay, once you're able to get them, then you just do the substitution. Okay, so let's substitute them. Okay, so if you substitute these values, this is what you are going to get. Okay, yes, so that's what we have here. Let's substitute it back, and then we have 14, square root of 14 on 3 minus 6 on 3 all squared. The 3 is the number of what the scores. Okay, so we have 1 2 3, so 3 scores. Okay, yes, that is great. Now if you work your way out, so this one you can work this, you can use your calculator and get the answer straight away. So what answer are we going to get? If you work with this one, then you are going to get 0.81. So it means if you find the standard deviation of these 3 data sets, these 3 sets, you are going to get 0.81. Okay, now based on this question, what it is trying to say is that, because this question stated as that if the scores of each student is decreased by 9, so let's take it as like this set that I've given, that we've calculated the standard deviation. Let me take it as if each of this is reduced by 1. Yes, like what the question is saying, that if their scores were to be reduced by 9, I'm taking this as these were the scores, and I'm going to reduce it by 10. So we are reduce it by 1. So I'm going to reduce each of the numbers by 1. Then we calculate for each standard deviation and compare whether we will still get the 0.81. Then you understand what I'm trying to say, that no matter what, whether we decrease the numbers or the set, or we increase it, it's not going to affect the standard deviation. The standard deviation is still going to be the same. Okay, so if that's the case, if we reduce 1 by 1, we are going to get what? 0. If we reduce 2 by 1, we get 1. If we reduce 3 by 1, we get 2. So we are going to have for 0 1 and 2. So we have reduced this by 1 1 1, have gotten this. So we are going to use 0 1 and 2. We are going to find the standard deviation of this and compare the answers. So as you know, for the standard deviation, so we find the sum of the scores. Okay, that's sigma x, and then we find the sum of the squares of the what scores. So when you square each of them, and then you are getting this. Then once we get this, we just substitute our values into the formula. You know, we did it in the previous one. Okay, so we substitute your values, and what answer? So you realize that if you use a calculator to Q this, you are going to get what? The same as what? 0.81. Have we gotten the point? Yes, that is what we are going to get. Okay, so you realize that even as these numbers were reduced by 1, when we calculated for the standard deviation, we still got what? The 0.81. So this suggests that the standard deviation is not affected when a constant term is either added or subtracted from the data set. It doesn't affect what? The standard deviation. So in this case, once it doesn't affect it, the standard deviation remains the same. Then it means that 15 given as our standard deviation will still be the standard deviation. In that case, our answer is what? The A, which is what? The 15. Okay, so if you compare the two, you see that they are the same. Have you gotten that? Yes, they are the same. We are getting the same 0.81, 0.81. Then our option is what? A. So please understand this concept. Okay, understand this principle. So when you meet it anywhere, if the question has also had stated that the score of each student was increased by 9, it will still be what? The same. It will not change the standard deviation. So please get this straight. Okay, if that's the case, then let's solve the last question, which is the question 11. So that will be our last question for the day. Okay, now in the question 11, we are saying that if the area of a rectangular field is 2000 square meters and its width is what? 40 meters, what is the perimeter of the rectangular field. So this one we are also dealing with what area and what perimeter. This is mensuration. Yes, so you did a mensuration. Okay, so let's look at how we can go about it. Great. Good. So this one is what mensuration one. Okay. Yes, area and perimeter of plane shapes. Do you get it? So this one, before you find the perimeter, you see that you are given the area and you are given the width. Know that a rectangle. So let's take this as our rectangle. Okay. Let's take this as our rectangle. Good. Now you know that a rectangle has what? The width and what? The length and the width. And opposite sides are equal. So we have two length and we have two what? Two width. Okay, great. So since the width is given, then we need to find the length. Okay, before we be able to find the perimeter. Okay, so if that's the case, then we know that we have the length, which is the longer side, and the width, the smaller side. Okay, yes. So once we have the width as what 40 meters, then we can calculate for the length using the area. And we also know that area of a rectangle is given as what? Length times what? Width. Yes, we know that area of a rectangle is length and width. So we just substitute our values and get our L. Area is given as what? 2000 squared. Have you gotten that? So it is not anything difficult. These ones are basic. So we just substitute our values and then after that we divide both sides by what? 40 meters. Then we can divide and get our L to be what? 50 meters. Have you got it? So you see that this questions, all the questions are very simple, simple. You don't have to waste much time. Okay, yeah. So once we have gotten the length as 50, then we can decide to label them. Okay, put them in their respective what size. Okay, so you know that all these are the size. Then working for the perimeter becomes easy. Okay, so when we talk of perimeter, what does it mean? So perimeter, we are talking about what? The distance covering what? An object. Okay, the total distance around an object. Whatever object you have, when you go around it, that gives what? The perimeter. So once we have a rectangular shape like this, and we now know all the sides, it's just a matter of what the distance around it. So we just sum all the sides, we add all of them. Okay, so it's just a matter of adding 50 to 50, 40, and then 40 again. So sometimes we even use a formula where we have perimeter to be 2L plus what? 2W. That means we have 2 of the length and we have 2 of the width. Okay, but understand the concept that it doesn't, we are not dealing with formulas. Okay, we are dealing with what? Concepts. So just a matter of what? Understanding that perimeter is just what? The distance covering what? An object. All right, yes. So if that's the case, then how do we work? We find the perimeter, and finding the perimeter, we just get what? Our answer to be what? 180 meters, and that answers what? The question. So in our option we have 180 as A, option A. So that is answer. So this is very simple. Okay, and this brings us to the end of today's lesson. So please, colleague teachers, students across, kindly go to Mazris TV. Follow me. Okay, follow me as I bring to you most of the exciting and most important concept of mathematics concepts. Okay, so if you have any challenge, if you don't have understand any concept, please contact me. I will guide you, especially those who are here to take their licensure exams in October and maybe next year or whenever. I'm available. So if you need my help to guide you, you can contact me. Okay, yes, you can leave a message under the comment section. TikTok, you go to, can send me message on TikTok, and I will reply you and we see the best way I can help you. Okay, so I'm still your mathematics facilitator Data Evans Okai, and this is Mazwis TV. Kindly subscribe, like, and share the videos for me. So see you next time. Bye bye.